Infrared astronomy is the branch of astronomy and astrophysics that studies astronomical objects visible in infrared radiation. The wavelength of infrared light ranges from 0.75 to 300 micrometers. Infrared falls in between visible radiation, which ranges from 380 to 750 nanometers, and submillimeter waves. Infrared astronomy began in the 1830s, a few decades after the discovery of infrared light by William Herschel in 1800. Early progress was limited, and it was not until the early 20th century that conclusive detections of astronomical objects other than the Sun and Moon were detected in infrared light. After a number of discoveries were made in the 1950s and 1960s in radio astronomy, astronomers realized the information available outside of the visible wavelength range, and modern infrared astronomy was established. Infrared and optical astronomy are often practiced using the same telescopes, as the same mirrors or lenses are usually effective over a wavelength range that includes both visible and infrared light. Both fields also use solid-state detectors, though the specific type of solid-state detectors used are different. Infrared light is absorbed at many wavelengths by water vapor in the Earth's atmosphere, so most infrared telescopes are at high elevations in dry places, above as much of the atmosphere as possible. There are also infrared observatories in space, including the Spitzer Space Telescope and the Herschel Space Observatory. The discovery of infrared radiation is attributed to William Herschel, who performed an experiment where he placed a thermometer in sunlight of different colors after it passed through a prism. He noticed that the temperature increase induced by sunlight was highest outside the visible spectrum, just beyond the red color. That the temperature increase was highest at infrared wavelengths was due to the spectral index of the prism rather than properties of the sun, but the fact that there was any temperature increase at all prompted Herschel to deduce that there was invisible radiation from the sun. He dubbed this radiation calorific rays, and went on to show that it could be reflected, transmitted, and absorbed just like visible light. Efforts were made starting in the 1830s and continuing through the 19th century to detect infrared radiation from other astronomical sources. Radiation from the Moon was first detected in 1873 by William Parsons, 3rd Earl of Ross. Ernest Fox Nichols used a modified Crookes radiometer in an attempt to detect infrared radiation from Arcturus and Vega, but Nichols deemed the results inconclusive. Even so, the ratio of flux he reported for the two stars is consistent with the modern value, so George Reek gives Nichols credit for the first detection of a star other than our own in the infrared. The field of infrared astronomy continued to develop slowly in the early 20th century, as Seth Barnes Nicholson and Edison Pettit developed thermopile detectors capable of accurate infrared photometry and sensitive to a few hundreds of stars. The field was mostly neglected by traditional astronomers though until the 1960s, with most scientists who practiced infrared astronomy having actually been trained physicists. The success of radio astronomy during the 1950s and 1960s, combined with the improvement of infrared detector technology, prompted more astronomers to take notice, and infrared astronomy became well established as a subfield of astronomy.